So before I forgot, I will record all my, if anything happens to Zoom, it'll be recorded and it will be uploaded to YouTube. And the link will be posted in D2L, and I also emailed you the link. Anything that I written down on the on here, it will be also posted in D2L and also emailed to you, so you get a copy of those two. So let's continue what we have. So the first step is to figure out where's A, B, C, D, and don't forget the formulas. This is very important. Amplitude in this case is the absolute value of A. Period is 2 pi over B. And phase shift is C over B. So these are the formulas to find your amplitude, period, and phase shift. Next, once you figure out your ABCD and your amplitude, period, and phase shift, the second thing you need to do is giving me the 5 original coordinates. Okay. So these 5 original coordinates are used, depends on what graph do we have. So if you have a sine graph, this is very important, class. If you have a sine graph, then the coordinates are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. If it's a cosine graph, then the coordinates are 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1. So these are the coordinates you use for cosine. Okay, so that is the second step. Third step is to figure out all your x values. So to figure out all your x values, in this case, you have 5 of them. So don't forget, this is your x and this is your y values. So in order for us to figure out x values, you have to take where it starts and where it ends. Okay. You start from bx minus c equals to 0, and you solve for x. It ends at bx minus c equals to 2 pi. So 1 is equal to 0, 1 is equal to 2 pi, and that is where it ends. Okay, so the starting point and ending points. And then you have to take the period divided by 4 to add this value, so that every time when you, because we got 4 quadrants per whole cycle, so you have to do this I think it's 5 times or 4 times, because you're going to do it every time you move to one coordinates to another coordinates. So you do need to do it like till you reach to the end part of it. Okay, so this is how you figure out your x values. And then the last thing is to figure out your y values. So in order for you to figure out your y values, is you take all the y values that you have in your original coordinates. You will multiply this by a. Again, a in this case is the number in front of the sine, cosine. Add or subtract d. Again, d is the number that you added or subtracted at the end there. And this will affect your y values. And the last thing we have to do here is draw 2 cycles. Okay, so this is something that I will suggest you guys to know. And again, class, this is super, super important. Okay, so we did this on Wednesday, so we will do it again today. So I think we stop at question number 8, and we will continue with question 8 here on today's class. So we have
step 4 again.
I'm sorry, go.
Could you show step 4 again?
Step 4 is you take all the y values in here, you multiply by the a, and then you add and subtract d. That will give you the y values. And again, this you have to repeat 5 times. The reason why you need to repeat 5 times here is because you got 5 y values given to us. So you have to do this for 5 times. So if you are doing sine, you have to take the 0, 1, 0, -1, and 0. You have to take all these y values, and you have to multiply with the a, depends on what a is, and you have to add or subtract d. So this is how we're gonna do we're gonna do this for 5 steps for question 8 here. This is where we stop. So by looking at question 8, y in this case will be 2/3. A in this case will be 2/3, because that is the value in front of the sign. B is the one that is inside the parentheses or next to your x. B in this case will be 1/2. C in this case will be the number next to the x inside the parentheses. So make sure you know that if it's a negative, then it is a positive. So this is actually positive pi over 4. And for this question, D, we don't have it. Okay, I put 0 here. So we don't have any D involved for this question 8 is because we don't have anything add on to it. So with this, we can figure out what is your amplitude. So the amplitude is the absolute value of A. So in this case, it will be 2/3. Your period in this case is 2 pi over B. Since our B is 1/2, or in this case 0.5, our B here is half of 0.5. So you need to divide this. Now, as we know that when you divide, so this is the same thing as 2 pi divided, I don't have the divide symbol here. So we can change the divide to become multiply. Then what you need to do is you have to switch your fraction around the back. So this is actually 4 pi. And for phase shift, we will have to use C over B. So no room here. So in this case, C will be pi over 4. And then you have to take this pi over 4 divided, that's just C, by your B, which is 1/2. And again, class, in order for us to do this, this is the same rules happens. You have to change the division to become multiplication. So the pi over 4 is still pi over 4, but then you change the division to multiplication, and you're going to multiply by the reciprocal. So 1/2 in this case will be 2. So this will become pi over 2. Yep. So so that is your first step. So let me save this so you guys can see this when I read it down, because sometimes it's hard to type on a Word document. So that's why sometimes it's hard to teach using Zoom. Okay, so just doing question 8 here again, so you guys can see it. Should use that. Oof. I miss my, so y is equals to 2/3 sine x/2 minus pi/4. So a in this case is 2/3. B in this case will be 1/2. And C will be pi/4. So in order for us to figure out what is your amplitude, that is your absolute value of A. So in this case will be 2/3. To figure out your period is 2 pi over B, and our B in this case is 1/2. So this is the same thing as 2 pi divided by 1/2. And again, we can always switch the division to become multiplication by flipping your second fraction. So that's why your period in this case is 4 pi. And then for phase shift is C/B. So C in this case is pi/4 divided by B, which is 1/2. Again, this is kind of the same thing we do just now. So pi/4 divided by 1/2. And the division can be changed to become multiplication. You just need to flip your fraction become 2. So this is become pi/2. So this is your amplitude, period, and phase shift for this question. This question is a sine graph. So the original points for the sine wave is going to be 0, 0. So that's your first original points here. The next one in this case will be pi/2, 1. The next one will be pi 0, followed by 3 pi/2, -1. And the last one is 2 pi 0. So these are your 5 original sine wave. This is actually your second step. So first step is doing all this work. Second step is doing your original point. Third step is to figure out what is your final points. So in order for us to figure out your final points, you need to use where it starts and where it ends. Now this is talking about the x value I'm talking about. So the starting point in this case will start at the bx minus c. In other words, everything inside this parenthesis. So it will be x minus 2 minus pi/4. And this is going to be equals to 0. That's where the starting point. And we will use the same thing, bx minus c. So x minus 2, x divided by 2 minus pi/4. And this is all equals to 2 pi. So again, I'm doing what is the starting and the final point of your x value. We don't do the y, we'll do the y value later on. So we'll begin to solve for x for each case here. So I will add pi/4 here. So x/2 in this case will be pi/4, because 0 plus pi/4 is pi/4. And then we will multiply both sides by 2. So x in this case will be pi/2. So we will start at pi/2. And we were going to end, so we're going to add pi/4 here. So again, we are solving for x. So x/2 is equals to, we're going to add these 2 up. So when you add 2 pi plus pi/4, this is over 1. So I can multiply this by 4 to make it the same denominator. So this is 8 plus 1 pi, so it's 9 pi/4. And then we will get rid of the 2, so I will multiply both sides by 2. So x in this case will be 9 pi/2. So this telling us that we will start at pi over 2 and we will end at 9 pi over 2. Now, this is just your starting and ending point for your x values. So we need to figure out what do we need to add on to it so that you will know what is the next x value. So in order for you to figure that one out, you have to take your period divided by 4. The period that we found early on in this question is 4 pi. So we will divide this by 4. So that means we need to add pi on it. So what we're going to do here, class, is in order for you to figure out what is the next x value here, you will have to add pi. So this will become 3 pi over 2. So this is like 50 cents, half is 50 cents. 50 cents past $1, you got $1.50. And then you add another, for the next one, you have to add another pi. So 3 half or $1.50 plus $1, this becomes 5 pi over 2. And then you have to add another pi for the next, the fourth coordinates. So that will become 7 pi over 2. And then you add another pi. This is where it ends at 9 pi over 2. So this is how you figure out your x values. So that's step number 3. It's a lot of work here. And lastly is to figure out your y value. So in order for you to figure out all your the y values, you have to multiply this by a, and you have to add or subtract d. And you're going to do this for 5 times because we got 5 y values that we will use here. Okay. A in this case is 2/3, so we will need to multiply all your y values by 2/3. The good news is we don't have a d because we don't add anything here. So we do not need to do anything with d. So we just literally need to take all this y value and multiply with 2/3. So 0 times 2/3, you get 0. 1 times 2/3 is 2/3. 0 times 2/3 is 0. -1 times 2/3 is -2/3. And then 0 times 2/3, you still get 0. So this is how you figure out your y value in this case. So this final 5 points that we just found is where you're gonna graph this for 2 cycles. Now, I recommend you to take a graph paper because, so I'm gonna have to use this graph paper. Now, because if I want to use this graph paper, I cannot draw on it. So I can put points on it, but make sure you guys have to help me to draw it out, okay? I can only allow to put points. Please, you guys know how to draw, right? Once I put the points up. Now, the first coordinate points that we will use here is pi over 2, 0. This is where a lot of students make a mistakes in here. Is, as you know, that a lot of people say, oh, this one, we're going to use pi over 2. Okay, we're going to put the first line or the first box here is pi over 2. And then the next one in this case will be 3 pi over 2. So, so where are you going to put 3 pi over 2? So that is all these little things that you have to watch out. Now, if you remember last time where we do our little dots, you always put the next one on the next box. So a lot of people will put 3 pi over 2 on the next line here. Okay. I just want to point out to you that that is going to be wrong. Okay. So why I say it's going to be wrong. So I just let you see what's going on here. So these are the boxes, right? If you put this as pi over 2, and if you put the next one after the box is 3 pi over 2, yeah, this will be going to be wrong. Does anyone know why this is wrong? This is wrong. Yeah. And your graph will look funny if you do it this way.
Should it be just pi then, instead of pi over 2?
Yes, because if you go one box is pi over 2, which is half. If you go another box, you have to add another pi over 2. So that is not 3 pi over 2. That is actually pi. So this is actually going to be pi. So where is 3 pi over 2? 3 pi over 2 is actually on the next box. So there's something that you need to watch out for this kind of work here. Not necessarily always like, oh, this is pi over 2, the next one is 3 pi over 2. And so you want to put 5 pi over 2. 5 pi over 2 is the 5th box, because every single one of these is 1 pi over 2. And then the next one we have 7 pi over 2 will be another 2 box, or 2 square away. And then the last one is 9 pi over 2 will be the last box in this case. The last 2, I mean the 9th. So when you guys want to put 3 pi over 2, you have to be careful, because this 3 pi over 2 should be on the 3rd line, not the 2nd line. And then when you go to 5 pi over 2, that will be on the 5th line, or 5th box in this case. So 1, 2, 3, 4, 5. So it's right over here. And then 7 pi over 2 will be on the 7th one. 1, 2, 3, 4, 5, 6, 7. So this is 7 pi over 2. And then the last one is 9 pi over 2, which is this one. So what you're doing here is now you have to do your 2/3, because you got 0, 2/3, and negative 2/3. So I'm going to count every 3 for each as 1, because then we can figure out that 2/3 means 2 parts of it, right? So this is -1. So the first coordinates point we have in this case is pi over 2, 0. So pi over 2, 0, I'm going to use straight point so you can see it. Pi over 2, 0 is right over here. This is pi over 2, 0. And then the next one is 3 pi over 2, 2/3. So 3 pi over 2 is right here, and 2/3 is somewhere around there. And then the next one we have is a 5 pi over 2, 0. And 5 pi over 2, 0 is right over here. Followed by 7 pi over 2, 2/3. So again, because I break this into 3 sections, so 2 of them is 2/3. And the last point we have is 9 pi over 2, 0. So which is right over here. So you will draw the sine wave in this case. So your sine wave will be a hill and a valley. So again, this is a part you have to draw it for me, because I cannot draw it out. So you kind of draw it out, and I need 2 cycles. So how do you figure out 2 cycles here? We do not have enough room to put another cycle here, because it's almost out of graph paper. So we have to force to use the negative part. So you notice that every 2 boxes, you have a unit. So in this case, for us to go on to the next one, you have to move 2 boxes, and then it will goes down. So this is for negative 2/3. And then you move 2 boxes to put it up. 2 boxes, you go to 2/3, and then 2 boxes, you get back to 0. So this last part of this, it will be your second cycle in this case. So this is how you draw this question 8 graph in this case. Let me see if I can draw more for you guys so you guys can see it. Again, I draw a lot of dots here so you guys can kind of figure out what it looks like. And again, class, when you draw this block, graph, don't do zigzaggy. It means make sure your curve is a smooth curve. Okay. Again, it's very difficult for me to draw on here, as you guys can tell that. So you guys kind of got what is going on here, right? So this will be your cosine, your answer for question number number 8 here. Questions? This is super tough. I didn't say this is easy. This is really, really hard here. Okay. So this is how we draw the sine graph. So I did mention on Wednesday is I give you the this few questions that we did here is I give you the equations, you draw me the graph, and then on one end I give you the graph, you have to give me the equation. So this is where it gets a little bit, you know, different. The work that you need to do here is a little bit easy because this question is asking us to find what is A, B, and C, given us that this function is a sine function that matches the graph given below here. So how do we figure this one out? So please pay attention. So in order for us to figure out what A, B, and C is, we don't have a D. Why do we don't have a D is because you find out that with the graph here, we didn't go up or down. Okay, so if you did move this graph up or down, then we have a D. Now it says it is a sine wave, and we know that a sine wave is a hill and a valley. So we will capture a one sine wave. Now this graph has multiple hills and valleys. So we will only capture only one of the hills and valleys, one cycle in this case. And we want to get that cycle so close to your y-axis. The reason why we want to get it so close to the y-axis is because we want to figure out what kind of phase shift they have and what kind of period they have. So you can use a sine wave that is not close to the y-axis, then you will have a different types of graph, a different types of answer. But you will still get this, but it's the equal, the functions are equal. So let me show you what I'm trying to say here. So example in this case that in order for me to pick which one that I need to use for this sine wave is I have to pick the one that has a hill and the one that has a valley. So this sine wave is what I'm talking about here, because this sine wave will give us a hill and a valley, and it actually starts at 0, 0. That means that it doesn't have phase shift in this case. Okay, so so what you need to do here, class, is if you pick this red box, then we will concentrate on this red box to figure out your sine, the ABC here. Now, some of you did not want to pick that red box. They will pick this red box, which is fine with me too, because it is a sine wave. But if you pick this red box, then you need to watch out that we do have a phase shift here because you are moving to the left here. So your answer is a little bit different from my answer, but it is the same sine functions we have. So it depends on where do you put the box. Now you cannot pick a box like this, and the reason why you can take a box like this, then it was telling us that your sine wave in this case will be inverse, or your A in this case will be negative, because a sine wave is usually a hill and a valley. But if you do the valley and the hill, it's telling us that your A here is negative. Now we do not want to have a sine wave like this, because this is not even a sine wave. This is more like a cosine wave because it is a huge peak. So you have to watch out where do you, and this is not also a sine wave, this is a cosine wave. So you need to watch out where do you want to put the box at. But the question will tell you, are we using sine or cosine? So for me, the best way for you to use the box is this box, where it starts from the y-axis and it goes positive. Try not to go to negative. You can, it's not wrong. So first thing first is we have to find what is A first. Now A in this case is the kind of like an amplitude. So how tall it is. We have a formula to find A is the maximum minus the minimum divided by 2. So if you look at your sine wave here, the maximum in this case is 3. This is your max, 3, and your minimum is -3. So in order for you to find this, this is 3 minus -3 divided by 2. So we know 3 minus -3 is 3 plus 3, which is 6. So this is actually 6 divided by 2, which is 3. So your A in this case will be 3. Another way you can figure out A in this case is what is the height of your amplitude from this to there. So we know the height here is 3. So so your amplitude here, your A in this case will be 3. Okay. So this is how we figure out your A. Next, we have to figure out your B. Now, B in this case is depends on your period, because the formula to find period in this case is 2 pi over B. Now, you have to look at this box, because this box will actually tell us what is the period of this graph. Now, I'm going to move this box away so you can see. So this period, one full period of this sine wave is actually half pi. Or another meaning is pi over 2. So this is pi over 2. So this telling us that your period of this graph is pi over 2. That means one full cycle of the sine wave is pi half. And then if you look for the other one, pi half plus pi half, you get pi. So that means that every pi half, it is a new cycle. Okay. So what do we do here is we just substitute the period here. So since we know the period is pi over 2, so we will solve for B. Now this is very difficult to see because it's all full with all those things. So if I just make it to write on here, so it will be pi over 2. This is your period, and this is equals to 2 pi over B, and we need to solve for B here. Don't forget, our main goal here is to find A, B, C. So in order for us to solve for B in this case, we just cross multiply. So pi times B is B pi or pi B, doesn't matter. 2 times 2 pi is 4 pi. And then we divide everything by pi, because again, we are solving for P here. So we find out that your B in this case will be 4. So we found the B. So when you solve for B in this case, you found out B in this case will be 4. Okay. The next thing we're going to talk about here is phase shift. Phase shift in this case is based on C over by B. Okay. Now the good news there, we know B. B is 4. So we need to figure out C. So how do you figure out phase shift in this graph? Is if you use this box, you find out that the phase shift in this case is 0. Why the phase shift in this graph is 0 is because your point starts at 0, 0. We did not move the point to the left. We did not move to the point to the right, because phase shift means you move your graph left or right. But since we did not move the graph left or right, we use this and it's right on 0, 0. So that's the reason why that your phase shift in this case is 0. We didn't move anything. So for this case, since our phase shift is 0, and B in this case is 4 from what we found early on. So we found out that C in this case is 0, because 0 divided by 4 is 0. So your answer in this case is f of x. So this is your answer. So your answer in this case will be f of x equals to A in this case is 3. Sine B in this case is 4x. Minus C, and C is 0. And again, the 0 is up to you if you want to write or not. So your answer in this case is 3 sine 4x. So this is how you do this question. If a question provides you the graph and they want you to give you the function of the sine. It's a little bit tricky, and that's why you need to figure out where is the box that we're talking about. Now, if I change this question to become f of x equals to a cosine of bx minus c, yes, I can change the cosine. Then we are not using this box anymore because this is no longer a cosine wave. A cosine is a whole value. So for a cosine wave, let me figure out if I can do a new, because this one will be very complicated. Then I will use this box. So this is the box I will be using. That is the cosine wave that we'll be using because cosine is the whole value. So this is the cosine wave. So for us to figure out what is the cosine wave, you find out that your A in this case is still 3 because the distance from the midpoint or middle till the minimum or maximum is 3. Now the period is going to be a bit tricky to find because they don't tell you what is the value of these two numbers. Okay, usually this is not fully given, but if there is a value, let's say, I'm just saying, let's say, I don't know, it's hard to tell what are these numbers because it's, let's say that this is pi over 2. Let me see. This is pi over 2, pi over 4. This is pi over 8, I believe. Again, usually they will give you what is that number is. Pi over 4. This is gonna be 5 pi over 8. Okay, let's say they give you that this value here is 5 pi over 8, and this value is pi over 8. So in order for you to find what is the period for this case, you have to subtract those two out. So what is 5 pi over 8 minus pi over 8? You will get 4 pi over 8, which is the same thing as pi over 2. So you notice that no matter where you move, if you have the same graph, if you move your box, you notice that your period, it stays the same. Since your period is the same, then it will tell us that your B is also going to be 4, 2, which is right here. Okay, so this is exactly how we figure out your B in this case. And the last thing is we have to figure out is phase shift. Now, this is the special case because our phase shift in this case is been moved. It used to be at 0, 1. Now it is been moved to this coordinates. So your phase shift is being moved in this case, and it will be moved to pi over 8. So it used to be at 0, 1 or 0, 3 if you look at that, and then it moved to the right. So how do we figure out what is the C in this case is you use the phase shift. So phase shift formula is C over B. And since we moved pi over 8 to the right, so this is pi over 8. And B in this case is 4. So we have to solve for C in this case. So in order for us to solve for C, we will multiply both sides by 4 so that your 4 and the 4 in the denominator will be canceled. So you notice that when you multiply both sides by 4, you will get pi half.
What are you doing?
Fine. Got my phone back. Can I have my phone back?
Yes.
I want to text my mom.
Sami, you have questions?
No, I have no questions.
So C in this case will be pi over 2. So if you plug all this back into your equation, so if I want to get a cosine graph, then your answer in this case would be f of x equals to 3 cosine of 4x minus pi over 2. Now, it's very difficult as long as, I'm not saying it's difficult, it's just you need to really watch this really closely, okay? Again, why you guys need to learn all this work is because I do not know what is your major is. One of the most important features that you learn about when you do this is if you are a nurse or a doctor, because our heartbeat is a sine or a cosine wave. So when you look at the hospital, you got the beep, 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 beep sound. Every beep in our heartbeat is a sine. So they will figure, there's a one way they will figure out, are you feeling, you know, I know the whole flat line means you die, right? So the person died. So what happened is that depends on how high the beep is, then your heart is going to beat, will be beat a bit more faster. So that is the reason why that if, so there is a lot of applications that we use sine and cosine wave that you do not aware about, okay? One of them is the heart rate that I told you when you go to the hospital, you see that. Another one is microwave. All electromagnetic fields, they are using sine wave, cosine wave. Your radio signals is using sine and cosine wave. Your cell phone service is using sine wave, cosine wave. The only thing right now is they will change the sine wave, cosine wave to the digital wave. So instead of using a hill and a valley, they will use this. If you talk about digital, it will be going up like this. So this is what happens right now is, last time we call this as an analog. So if you have like an old VCR or something else, we are using analog wave. And then now we are using digital. So we can convert analog to digital by just changing your sine wave to become like a rectangle, something like that. So if you are interested on all those, that's what we call as electrical and E&E engineering. So you'll be studying a lot of those types. So your current, if again, E&E people, engineering, if you talk about current, your current that goes through an electric component is a sine wave component. You will learn all this when you guys move on to your field. That's the reason why that some of you are asking about why we use learning all these words. I do not know what field are you going in, but if you are going the designated field, you'll be using this quite a bit, and you'll be analyzing the sine and cosine. Questions? Now, again, I try not to scare you guys. Usually for my homework or my test, I don't move the full period to the right like this. Usually it's smack right on 0, 0. That is usually what I do for this case. Okay. You are just in the beginning part of learning this. So when you guys do more about your field of your work, you begin to explore this more. The next type of questions that I can ask you to do is, I give you what is the characteristic of this sine or cosine wave. You write an equation. So you do not need to graph. I just tell you that this is a sine wave, a sine curve with a period of 4 pi. The amplitude is 3. The phase shift is moved to the left pi over 4. And it's vertically translation down 1 unit. So this is, I give you the characteristic and you tell me what is the function or what is the equation in this case, okay? So as you know that this is a sine wave, so the equation in this case will be y equals to a sine bx minus c plus d. So this is the equation that we use here. Again, we need to know what is A, B, C, D here. And if you know them, then you can just plug everything in there. A will be the most easiest to find because A in this case is amplitude. Okay. So it's given us that this is actually a 3 because the question told us that the amplitude of this sine curve is 3. So we know A is 3. Now, until if the question says the amplitude is 3 and it is reflected to the x-axis. So if the question says it's reflected to the x-axis, then your amplitude in this case will be -3. The reason why that if it's reflected to the x-axis means that your graph is going to go upside down. That means you don't get a hill and a valley, you get a valley and a hill. So your A will be -3. So this is something that I will put if there is a reflections on the x-axis, then your A in this case will be a -3. But since there's no reflections going on, so your amplitude or your A in this case will be 3. Next, we have to figure out what is B in this case. So in order for us to figure out B, we use period. Okay. Because period in this case is 2 pi over B. And what is period? The question already told us that the period in this case is 4 pi. So this will be actually 4 pi equals to 2 pi over B. So again, I need to solve this over here because it looks nicer this way. So 4 pi is equals to 2 pi over B. Again, 2 pi over B is the formula that we use. So in order for us to solve for B, we will interchange your 4 pi and your B. So B in this case is 2 pi over 4 pi. And the pi will cancel out. So in this case, your B is 1/2. Okay. So when you solve for B in this case, your B in this case will be 1/2. Next, we have to do is phase shift. Phase shift depends on C and B. So sorry, you need to know your C. So phase shift in this case is C over B. And we really know B in this case is 1/2. Okay, B in this case is 1/2. Now this question is telling us that your phase shift is moving to the left. This is super important. Left of pi over 4. Now when you move to the left of pi over 4, it means that your phase shift is -pi over 4. Why your phase shift in this case is a negative? Because when you move things to the left, you move everything, move to the left means you go to the left side. So it means you minus, you put a negative. So that is your phase shift in this case. So this phase shift will become -pi over 4. So we will solve for C in this case. And again, I'm going to do it right over here so you guys can see how do we solve this. So a -pi over 4 is equals to C divided by 1/2. Okay, again, where is the 1/2? 1/2 comes from the B. Okay, C over B is a formula for phase shift. How do we get rid of this 1/2? I multiply by 1/2. Because on both sides, because they are divided here. So this 1/2 and 1/2 would cancel out. So if I multiply 1/2 here, I do on the other side. So C in this case will be -pi over 8. So for this case, we will find out that your C in this case will be -pi over 8. And the last one we're going to talk about is D. D is the most easiest one, is where you do a vertical translation. Since this question says you're moving down 1 unit, so your D in this case is -1. So you go down. So now you got your A, B, C, D. You just plug this all back to this equation. So your answer in this case is Y is equals to A, which is 3, sine times bx, which is 1/2 x, or x over 2 if you want to put it that way, minus your C, and your C is another negative pi over 8. B is -1. So again, this is your A, which is 3, B is 1/2, C is negative pi over 8, and D is -1. And we know what you need to do with this 2 minus sign. This 2 minus sign will become plus. So this is your equation of this function, given us that characteristic. I want you guys to try to do question 11 on your own now. Try to do this one. Again, start with your amplitude, your period, phase shift, and D. It's a cosine graph. Go ahead and try it. And I'll be right back with some water. So go ahead and try them. All right. Anyone got anything? Anyone? Anyone know what's A in this case?
Is A1?
Yep, A is 1. Yep, that's correct. Because that is your amplitude. Now we have to figure out what is B is. Well, B is 2. So can someone who say 2? Mosati, can you tell where you get how you get B is 2 in this case? What do we use for B? So B is, yep.
P is period, which is 2 pi over P.
Mm-hmm.
We have, from the equation, the period is pi.
Yep.
So if we do 2 pi over P, which is equals to pi, and solve for P,
Mm-hmm.
you get 2.
Yep. So when you solve for B, you will get 2. That is correct. So that is B is 2 in this case. That is correct. Next is your C. So anyone know how to get C in this case? Anyone see?
Is C pi over 2?
Pi over 2. And how do you get pi over 2 in this case?
You take the phase shift equals C divided by, C multiplied by B. And
C
B
over by B. Yep. This is your phase shift. Yep. And what is your phase shift in this case?
I might have got this wrong. The phase shift is pi.
Pi. Yep. Because you're moving to the right, so it's pi.
Mhm.
And what is B in this case?
2.
2. Yep. So how do we get for C in this case?
So you multiply 2 to each side. So then it would be 2 pi. I said
Yep.
that right.
So C in this case will be 2 pi. Yep. So I'm going to erase that fellow. So it's actually is 2 pi. And lastly is D. Anyone know D in this case?
It's just 3 over 2.
Yep, 3 over 2, because they are moving up by 3 over 2. So now what you do is put all this back into your equation. So your answer will be y equals to cosine. Again, if you put 1 in front, it's up to you. 2x minus 2 pi, because your B is 2 and your C is 2 pi, plus 3 over 2. Questions? Okay, so this is a bit easier, right, compared to those questions you did before. So you will get one of these kind of questions in your test on next week. I think I told you guys you will have your first test next Wednesday, not Monday, next Wednesday. So yes, you will get something like this in your first test. Next is the last question, 12 here. Is given us a function P is 100 minus 20 cosine 5 pi t over 3. This function is where you measure your blood pressure, where time t for a person at rest. So when you measure your blood pressure. So the question here wants you to find what is the period of this function. So period in this case is 2 pi over b. That's a formula. So can someone tell me, looking at this function, what is your b in this case? What's your b here? No, last time b is always next to the variable x, right? And here is 2, but we don't have a variable x, we have a variable t. So tx.
5 pi?
Close. 5
pi over 3?
Yes. So your b in this case will be 5 pi over 3. So what you need to do is put this inside the formula. So this is 2 pi divided by 5 pi over 3. And as usual, I'm going to show you in this way so you guys can see it. So So 2 pi, the divide will change to multiply. 5 pi over 3, you switch it to become 3 over 5 pi. And you notice that your pi will cancel out. So again, this is fraction. You just multiply them straight across. This is 6 over 5. So the period in this case will be 6 over 5. Okay. This will be bits per second. This will be millimeter per. This is per second. So this period in this case is all in seconds. So usually period is measured in this case time, t here. So they're all measured in seconds. Okay. Question B is asking us to figure out how many number of heartbeats per minute in this case. So this is something that, again, you probably will learn this when you go to either physics class. Yeah, it's a physics class. In order for you to figure out how many heartbeats we have, you have to take 1 over p. Okay. In order for you to figure out how many heartbeats you have, you just take the p, the period, you reciprocate it. So for this case, it will be 5 over 6. The same thing, you take the period you have for 6, 5 over 6. But this is seconds, beats per second. But the question here wants it in beats per minute. And we know that 1 minute has 60 seconds. So you need to multiply this by 60 to change it to become minutes. Okay. So again, it's conversion here. So 5 over 6 times 60 will give us 50 beats per minute. So this is how we find how many heartbeats we have. Is you take the period and you put it 1 over it, or in this case, you flip-flop it, reciprocal it, and you will get this in seconds. But since the question wants in minutes, we know 1 minute is 60 seconds. So we just multiply that by 60 and you get that in beats per minute. So this is how we do question 12 here. Something, not really crazy about the word problems here. So I think you don't have, no, you do have word problems, but it's not coming up from this section. As I mentioned, you do have a homework. This 6.4 homework is actually due this coming Wednesday, which is the 14th. Okay, so you do have this only one homework due this coming Wednesday, which is 6.4. Anyone have any questions before we do 6.5 here? Now, if you remember how we draw the graph of sine and cosine in the very beginning on Wednesday class, we did use your unit circle, that circle that you guys use, and we're looking for sine and we're looking for cosine, right? So we're gonna do the same thing now for tangent. Okay. So for tangent piece, what you need to do here, class, is you will look at the y over x. Remember, sine is for y, cosine is the x. So you look at tangent, and we begin to use the graph for that case. Okay. So so when you do a tangent graph, we will be using back the same coordinates we'll be using for sine and cosine. We use the 0. We will use pi over 2, pi, 3 pi over 2, and 2 pi. So what you guys need to do, class, is take out your unit circle and look at the y over x. So the first one we have is tangent 0 degrees. Anyone? Tangent 0 degrees? Anyone?
It's 0.
It's 0, yes. Because y over x in this case is 0, right? The next one is pi over 2. Pi over 2 is this fellow, which is 90 degrees.
Undefined.
Yes, this is undefined.
Yummy.
And then what happens to pi?
0.
It'll be 0. And 3 pi over 2,
Undefined as well.
this is undefined. And then 2 pi will be the same thing as 0, which is in the case 0. So this is something that I will tell you what it looks like when you have undefined solution, when you try to graph it. Every time when you want to graph an undefined solution, this is actually is your vertical asymptote. Let me repeat. Every time when you have an undefined solution, that on the graph represent vertical asymptote. You guys know what is a vertical asymptote? Anyone? What is a vertical asymptote? Is a vertical line that the graph will never cross. So at pi over 2, you will get a vertical asymptote, or in this case, undefined. So that's telling us that this tangent graph cannot cross on the pi over 2. And it happens again at 3 pi over 2. And you will get another vertical asymptote. So these are the two undefined cases here. And on the graph, undefined means vertical asymptote. And then you got 0, 0, because when x is 0, tangent 0 is 0. Pi, which is right over here, right in the middle here, you also get 0. And then 2 pi, you get 0 also. Now, as you know that you cannot cross on this line. So there is so many lines you can draw here. It can be a parabola, it can be any shape. So we have to figure out what are the points we will have to use so that we can graph this. Because if you have only got 1 point, you cannot graph the graph. So what do we do here is we add a few more. Now we know that pi over 4 is a very nice for tangent. Can someone tell me what is y over x for pi over 4? What's tangent pi over 4 is? Anyone? You're a unit circle, right?
1.
1, yes. So you notice that where is pi over 4? Pi over 4 is between pi half and 0. And you notice that that will give us 1. And if you go on to the other side, 5 pi over 4, does anyone know what is tangent 5 pi over 4?
One.
No, this will get 1. You get a -1 because this is in quadrant 2. So where is 5 pi over 4 is? 5 pi over 4 is between pi over 2 and pi. So this is 5 pi over 4. And it is a -1, which is right over here. So a really big orange dot here. And then what happens to the other one, which is 7 pi over 4? Oh, sorry. My bad. No wonder you guys, I got this all mixed up. This is not 5 pi over 4. Hello, this is 3 pi over 4, right? My bad. And this is not 7 pi over 4. This is 5 pi over 4. Hello. That's what happens when you get sick. You forget all this. So so this is 3 pi over 4. Sorry, my bad. So at 3 pi over 4, you will get -1. So this is, and at 5 pi over 4, you will get back 1. So 5 pi over 4 is between pi over 2 and 7 pi over 2. So you get back 1 here. And then at the last one, which is 7 pi over 4, and tangent 7 pi over 4 is -1, because it's in quadrant 4. So this one is right down here. So what do you notice is you got these two orange point and a green point, and you have a vertical asymptote, means you cannot cross it. So your tangent graph will look very similar like a cube function. So what do I mean by cube function? Oh, this is really, so they cannot cross on your asymptote, your vertical asymptote. So it goes parallel to it. And then right on the middle, it is kind of like going like a cube type. Okay. Same thing happens if I want to do it in more cycles. So the next one is, let's go on to the here. So that will be 5 pi over 4. 5 pi over 2, because that is the your undefined case in this case, because you will see pi over 2, 3 pi over 2, 5 pi over 2, and then right in between this is a +1. So the graph for this tangent is actually the same on this period. And if I go on to the negative side, so this will be -pi over 2. And again, at -pi over 2, this will be undefined. And then at right in the middle, this will be at the -1. So this graph will keep on doing the same cycle. So we do have a period now, because if you look at this, they all are similar. They're all like same. So that means that this is your period for tangent, because this is the same period and that is the same. So everything is like sine. Okay. So how do we figure out period for tangent? You look at your undefined. So it goes from -pi over 2 to pi over 2. So you just subtract them. So pi over 2 minus -pi over 2. So you notice that your period in this case is exactly pi. So on one full cycle, the period for tangent is pi. Another way you can look at this is right here. It goes exactly 180 degrees to get back the same value, because this is all +1 and this is +1. And then if you go on, take the other one and you go exactly 180 degrees, you get back the same thing. And 180 degrees is the same thing as pi radian. So you find out that the period for tangent is pi in this case. Okay. Now, what is the domain for this tangent graph? This is the tangent graph that we have. Now, as you know, that domain is all the x values you can have. But because we have so many undefined cases, so your domain in this case is all real numbers, except when x is equals to all these undefined cases. Now, you cannot say pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So we have to write this in the k pi form. So we will start this from pi over 2. And then we add k pi. So that means that if you, and k in this case are integers. So this is your domain for your tangent graph here. Means any real numbers work except pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Because those, if you take tangent of this, those numbers, you will get undefined cases. So that is domain. Range. Range is all the y values that you can take. And if you look at your graph go from negative infinity and then it goes to positive infinity. So your range in this case will be all real numbers, means it go from negative to positive infinity. This graph has a period of pi. Okay, and it is an odd graph. Again, what is odd? Odd is where it is symmetry with respect to the origin. So right over here is symmetry with respect to the origin. So in another meaning, tangent of a negative x is the same thing as negative tangent x. So this is what it means by odd function for tangent for geometry here. And we got the domain, we got the range, we got period, we got the odd. What is your x-intercept in this case? It cross on 0, 0. It cross on pi 0, 2 pi 0, 3 pi 0, 4 pi 0. So your x in this case, intercept in this case will be k pi 0. Again, k in this case is your integer. And your y-intercept will be at 0, 0 because they only cross at 0, 0. So this is the tangent graph that we'll be using. So every time when you do a tangent graph, you do not need to give me that 5 coordinates. Remember, sine, cosine, you have to give me that 5 coordinates. You do not need to provide this. The reason why is because that it is undefined on certain value. Because of this undefined on certain value, we just need to watch where does it start and where does it end. So what do we do here is, remember last time in the sine and cosine, we always take the bx minus c equals to 0. This is where it starts. Where it ends, we take the bx minus c equals to 2 pi. And the reason why we do that for sine and cosine is because both of those starts at zeros and it ends at 2 pi, right? Either one of those graphs, okay? But for this, we do not use 0 or 2 pi because we don't, tangent graph doesn't start from there. So you can pick where is the starting point. Now, if you want to start here, then it has to end on this side. So if you want to start with pi over 2, then you will say bx minus c should start at pi over 2 equals to pi over 2, and it will end at 3 pi over 2. And you will solve for x in this case. Okay. Now, if you do not want to use pi over 2 starting point and 3 pi over 2, you can also use the starting point is at any starting point you want. So any in this case, it has to be a undefined case. So you can use a starting point on negative pi over 2, and then you end pi over 2. So you can pick where you start and where you end, but make sure that you only have one full period in this case. You cannot start here and end on 2 periods, okay? That'll be wrong. So my suggestion, again, you can pick which one you want, right? My suggestion is to use this, where you start at negative pi over 2 and you end at pi over 2. This is the suggestion you will start. I will suggest you to use this too. You will later on figure out on Wednesday class when we do the inverse why we start from this and ends on that. Okay, but you can start and end everywhere you want. But I really the reason why we picked that is because it captured the y-axis. That's one. And then the second reason is because of inverse trigonometry on tangent. So you will figure out, we will talk about that on Wednesday class. Okay, so that's the reason why that when you do the starting point and ending point, we start from bx minus equals to -2 pi, and we ends at pi over 2. You start for x in this case. So we will do some examples on this tangent piece. Yeah, this is actually looks difficult, but actually it's not as tough as the sine and cosine. Okay. So so let's talk about that. We don't take tangents in this case. So let's take a look at question number 1 here. So this question wants us to sketch the graph of this function, and you have to include 2 full periods. So now on question 1, you got y equals to -2 tangent 3x. Now we do not have, you want to say your a is -2. You can do the same thing as what we did for sine and cosine. B is 3 because that is next to your x. We don't have c, we don't have d, right? Because we don't have those at the end there. Now, because of tangent has no amplitude. We don't use any amplitude for tangent. The reason why there's no amplitude for tangent is because tangent goes from negative to positive infinity. So amplitude is where you take the maximum and minimum, you subtract them, divide by 2. But since they are all infinities, so that's the reason why that when you do tangent graph, we don't calculate amplitude. There's no such thing. However, there is a period. Now, if you remember last time in sine and cosine, the period in this case is 2 pi over b. And the reason why your period is 2 pi is because for sine and cosine, the whole full cycle is 2 pi. But for tangent, one full cycle is only pi. So that's the reason why that when you do tangent, the period that we use here is just pi over b. So that's something different in this case. We still have a phase shift. So your phase shift in this case is still c over b. Okay. So your phase shift in this case is still c over b. And then we have d as usual, move up and down. Okay. So it's kind of very similar to what we did. The only difference is 1, tangent graph doesn't have amplitude. 2, your period is not 2 pi, your period is pi. And the third one is you do not need to give me all the original points. Remember last time in sine and cosine, you give me all the original points? No, you do not need to give me all the original points. So what do we do in this question is you take your bx minus c. You have a starting point and you will have an ending point. Now this starting and ending point is your vertical asymptote, because as long as you can tell me where is your vertical asymptote that you start and ends, then we know that your tangent will be inside there. Okay, so how do we know where is the vertical asymptote where you start and end? You take the bx minus c equals to -pi over 2. And for the ending point, you take the bx minus c equals to pi over 2. The reason why we use that is because, as I mentioned, if you look at the tangent graph we just draw, it starts at -pi over 2 and it ends at pi over 2. As I mentioned, you can use another one which is pi over 2 and 3 pi over 2, but I will suggest to use this 2. So if you look at this question number 1, our bx minus c in this case is 3x. So we will get 3x equals to negative pi over 2. And then 3x is positive pi over 2. So, so you solve for x, so I divide this by 3. So x in this case is, again, divide is the same thing as multiply. And then you switch to fraction, flip-flop this. So in this case, your vertical asymptote will start at negative pi over 6. And now you do the same thing, you divide this by 3. And it will end, if you again flip this to become 1/3, it will end at pi over 6. So what happened, class, is now if you want to draw this this graph, first you have to figure out what is your starting vertical asymptote and where is your ending vertical asymptote. So that is negative and positive pi over 6. So I'm going to use that to draw. I'm going to put it, let's put down pi over 6. I'm going to put 2 little follow here. So this will become negative pi over 6. And this is pi over 6. So every 2, then I will tell you why I picked 2 here. So every 2 is your pi over 6 and negative pi over 6. So this line is your vertical asymptote. And as you know that you cannot cross at this vertical asymptote. You guys got a hand on it. It's very tough to teach this. So this is your vertical. And if you learn this in your college algebra, how do you draw vertical asymptote? Is always a dashed line. And it's always start with x equals 2 because it's a vertical line. So this is your vertical asymptote. And if you draw your tangent graph, the middle of this will be 0. And then the middle of the middle is 1. And then the middle of the other side is a negative 1. This is the original of the tangent graph, where you get 1 and negative 1 on this case. Okay. And how do we know this is if you look back to the basic graph, the middle is always at 0 and then the middle. Now, what is the middle here? This will be pi 12 because that will be the middle between pi 6 and 0. And then that is a negative pi 12. This graph is true if you have y equals to tangent 3x. However, because you got a negative 2, which is your a in this case, your a in this case will affect your y value. So that's the reason why that when you want to do this, your graph will have to multiply all your y value by a. Remember last time when you do your sine and cosine, and then you have to add plus minus d. Okay, same thing we do in this case. So all the y values that you see here will be multiplied by a and then add plus minus d. Now the good thing is there is no d here, so you have to take all the y value in this case and you have to multiply this by -2 because our a in this case is -2. Now let's take a look at the point 0. Now this is your y value. Your y value is 0. If you take 0 times -2, you will end up back to the 0. So this point will be still stays back at here because 0 times -2 is still 0. But if you look at this point, your y value is -1. So what is -1 times -2? -1 times -2 will become +2. So what happens to this is your graph will move from -1, this point will move up to a +2. So this graph is no longer needed because it's been moved up there. Same thing happens to this. This y value is supposed to be at 1. So when you multiply by -2, 1 times -2 is -2. So this graph will move to -2. So this graph, this point is no longer there. So now you will get a tangent graph, but the tangent graph that you see here is going to be the opposite of, I'm going to draw it out. I'm not going to do that because it's going to be icky too. Yeah, I'm not going to do this one because again, I'm going to draw it on my, on here so that you can see it. So what happened is that you will have your vertical asymptote at -pi/6. And you have another vertical asymptote for pi/6. And how do you find that? Is taking those two. And then you will have a 0, 0. And then right in the middle between 0 and -pi/6, you will have a -2. And right in the middle between 0 and +pi/6, not negative, +2, sorry, you will get a -2. So your tangent graph for this will be look something like this. And again, it's a tangent graph, so it's not a straight line. It's going to be like curvy line like this. Okay, so it looks like a cube function, but it's been reflected on the x-axis, and it will not cross on the pi/6 in this case. So this is the answer for question 1. And since they want in 2 periods, so the next period will be right over here. And that period is actually pi, you have to add another pi/3 to this. How do we know the period here is pi/3? Is because if you look at your formula, period is pi/b, and this question, the b is 3. So that's why the period is pi/3 here. So when you look at this 2, the period here will be pi/3. So pi/6 plus pi/3, this will be pi/2. Or in other words, 3 pi/6. And your graph will be exactly the same. So right in the middle will be 0. Right in the middle between pi/6 and this will be at +2. Right in the middle between that and pi/2 will be -2. And you will get yourself another tangent graph that being moved around. So this is your answer for question 1. Now, the tangent graph is the tangent graph, although it's a little bit simple, you do not need to do a lot of work. But what I want to point out is, 1, make sure you know where your vertical asymptote starts and ends. How do you do this? Is taking bx minus c equals to -pi/2 and pi/2. And you solve for x, you get yourself your vertical asymptotes. And then the next thing you need to watch out is your a and your d. So this will be the one that determine if you want to flip it or not. If you have a is -2, means that all your y value will be multiplied by -2. And let's say your d is -1, means you have to move everything down 1. Okay, so your graph will be a little bit different once you flip around. Okay, so I'm going to give you another example of this tangent graph so you guys can see what's going on here. So it's a little bit different. Yeah, it's very difficult to teach, I can tell you that. Let's try another tangent graph. Y equals to 3 tangent 2x plus 1. Okay. So how do you graph this tangent graph? Okay, so we follow the the steps. Tell me your A, B, C, D. Now we don't have amplitude for tangent, but we do have period and phase shift. So this is the first thing, very similar to what we did on sine and cosine. So A in this case is 3. B in this case is next to your X, which is 2. We don't have a C because C usually is inside a parenthesis. There's no parenthesis here. And D in this case is 1. So don't forget, this is plus 1. But if I do this put in a parenthesis, then your C will be negative 1 here. Okay, we don't have parentheses here. The period in this case is pi over B. Since our B is 2, so it's pi over 2. Okay, we don't have phase shift because phase shift required C. C is, we don't have any C, so that is the first thing we do. Second step is to figure out your vertical asymptote. Where do you start and where do you end? How do you figure out where does it start and where do you end? You take the bx minus c equals to negative pi over 2. Because originally your tangent starts at negative pi over 2 and it will end at positive pi over 2. So if you look at this question, this 2x is your bx minus c. So we will solve for x here. So we will divide this by 2, which in this case is the same thing as multiply by 1/2. So you will get, oh, I forgot a negative here. So you will get a negative pi over 4. And you do the same thing on this side. So 2x equals to pi over 2. Again, we will divide this by 2 to get rid of the 2 here. So x in this case will be pi over 4. Now you notice that if we don't have a phase shift, your vertical asymptote is exactly the same, but one of them is positive, one of them is negative. So this one will become a positive pi over 4. This one will become negative pi over 4. So this is your vertical asymptote for this question. Third step is to take your y value multiply by a plus minus d. So the y value that you have here needs to be multiplied by 3 because our a is 3 and we need to add 1. How many y values you have to take? 3 of them. One is at 0, 0, 1 at 0, 0. One is at the middle part of this 1, and the other one is at the middle part of that negative 1. So what you need to do here is you have to take these 3 points on the y value, multiply by 3, and add 1. So this point used to be at 1. So once you multiply by 3, so 1 times 3, then you add 1. So this value will become 4. So this number is no longer at 1 now. It will be at 4. For the 0, so now we do the 0 because our y value is 0. You multiply by 3, you still get 0, and you add 1, this will be 1. So this point is no longer here now. It will move up by 1. And then the last one we have is a negative 1, which is this fellow. You multiply by 3, which is negative 3, and you add 1, this is negative 2. So this point is no longer here. It will be at negative 2. So this graph, please do not draw a straight line, and please don't cross on the asymptote, the vertical asymptote. So this graph will be kind of like a parabolic type. When I say parabolic type, it's really difficult to draw. It is kind of like straight parallel line, and then this will curve a little bit. And then I am really bad drawing this with a mouse. This is very difficult to draw with a mouse. So it will look something like this. Okay, so it will look something like this. Just want to tell you that it looks nicer. Okay, so this graph will look something like this. So that is how you draw the y3 tangent 2x plus 1. You can create another one because we need 2 cycles. So how do you figure out what is this cycle is? We look at your period. So your period is pi over 2. So you add pi over 2 in this case. That will give us 3 pi over 4, because pi over 4 plus pi over 2. A quarter plus a half is 3 quarters. And your graph will look exactly the same. So right in the middle of these two is at positive 1. Right in the middle of those two will be at 4. And right in the middle on the other end is going to be at negative 2. So this graph will look something similar. It's going to be really difficult to draw with the mouse. So this is your second period in this case. So the work that you put in here is definitely less than the sine and cosine, because you only need to do 3 steps. One step is to figure out your ABCD and your period and your phase shift. 2 is, second step is to figure out where your vertical asymptote starts and ends. And then lastly is to figure out where is your y value changes by multiply by A and then add, subtract B. So you do not need to build me that coordinates in this case. So this is how we draw a tangent graph. So when you come back on Wednesday, we will do the rest of it, which is the cotangent, the cosecant, and the secant graph. And then we'll begin to do all this, how you draw those graphs. Your secant and your cosecant graph is based on your sine and your cosine graph. So make sure you guys do your homework on the 6.4 first before you do on 6.5. Okay, that's it for today. We will see you guys back on Wednesday. So if I'm feeling better, then the class is going back to in person. If, however, I feel sick, it will be back to online, which I do not want to do it via Zoom. I hate it. I'm gonna go to the pharmacy and get some medicine now, because I just see the doctor today and my phone is buzzing like crazy. So I will hopefully see you guys on Wednesday. Now, also want to tell you that tomorrow on Tuesday, we don't have class. I know we don't meet on Tuesday, right? But North Southampton has no school on Tuesday, so for tomorrow. So if you have any classes for tomorrow, night class, day class for tomorrow, you don't have any classes. So I'll see you back on Wednesday. Check your emails. Okay. Anyone have any questions? Tenzin, I will announce it to you on Wednesday. And the answer in this case is yes. You are allowed to use 1 page of notes. Not, I don't think so, you are allowed, and not the unit circle. So you actually have to combine those into 1 single sheet of notes. Okay. Yeah. Yep. So I'm